The geysers is a very unique area. We currently have about 330 active steam production wells. Those produce enough to power the equivalent of the city of San Francisco.
When I was younger, I never got the opportunity to even know what renewable energy was. It's going to be awesome.
The city has plans to be zero net energy by 2025, and the solar facilities are essential for achieving that goal.
Bay Area Bountiful is about agriculture. It's about feeding us. It's about land and water. It's about the health of our planet. It's about stories that matter. Bay Area Bountiful. Cultivate, celebrate, connect.
Bay Area Bountiful is made possible in part by Rocky the free-range chicken and Rosie the original organic chicken. The Sonoma County Agricultural Preservation and Open Space District, Made Local Magazine and Sonoma County Go Local, and through the generous support of Sonoma Water.
The Bay Area is often a leader when it comes to advancements in technology. Renewable energy is no exception. Solar, wind, and wave energy have become major subjects of research, investment, and implementation. But those aren't the only renewable energy sources available. Because of its geographic location, the North Bay region is a hotbed of geothermal energy production too.
You might want this.
A complex of geothermal power plants known as the geysers occupies around 45 square miles in the Mayacamas Mountains, on the border of Sonoma and Lake counties. At 725 megawatts, it is the largest geothermal plant in the world.
My name is John Avery. I work for Calpine here at the Geysers Power Plant. This is our visitor center, and let's take a look in the exhibit hall. One question about geothermal is why isn't there more geothermal? Why aren't there more geothermal power plants? And so one of the reasons is explained here on this display. What you need for a geothermal power plant is you need heat, you also need a fluid like water or steam, and you also need rock that is fractured and permeable, and you need it at an economically viable depth. And that only occurs in certain places in the world, and the geysers is one of those special places where our deepest well here is less than 3 miles deep, about 2.5 miles deep. And so this map shows where there are geothermal sites around the world, and circled are where the power plants are mostly located. And you can see it's mostly around the Pacific Ring of Fire, also some sites in Europe, Italy, and Turkey. Not shown well here is the Kenya East Rift Valley area. And so these geothermal hotspots, like these here around the Ring of Fire, are typically found at the interfaces of tectonic plates.
This is the boundaries essentially of the Pacific Ocean, where we have where we have the Pacific Plate and the surrounding plates essentially all banging against one another, one descending beneath another, sliding past another, and the result is a lot of heat in the Earth's subsurface because of this. So there are significant, there is significant potential for geothermal development all around the Pacific Ring of Fire. And just as a reference, there are like 452 volcanoes that exist around this Ring of Fire, and about 90% of all of the larger earthquakes happen around this too. The geysers is a very unique area, and it results primarily due to the intrusion of granite approximately 1.1 million years ago, very near the surface in this part of California. That set the stage for the development of the geothermal reservoir that's here. The high content heat above the granitic intrusion embrittled the rock and set up the conditions for a fractured reservoir at the geysers.
With 330 steam wells, 72 injection wells, 13 power plants, and almost 90 miles of steam tubes, the geysers sounds like it would have quite an ecological impact. But the green energy of geothermal truly lives up to its name.
This well pad, which is several acres, is actually taking steam from dozens of acres cross-sectionally below us. So it's minimal surface disturbance compared to the amount of power we're able to take out of the ground. You can see that our steam lines follow the roads here, so we're also minimally disturbing the surface there. So I'd say we're pretty equivalent to a wind farm, much less disturbance of the ground than compared to a solar panel farm.
At the geysers, we currently have about 330 active steam production wells, and those produce about 725 megawatts of electrical power, which is enough to power the equivalent of the city of San Francisco.
So this is where the steam comes in, from all the different wells and the cross-tie pipelines. And it comes into the power plant here, and then you can see this main steam line running through the yard and then into the turbine building.
After the steam enters the plant, it goes through a series of valves and into a turbine where the pressure against the blades spins a giant rotor. That motion is transferred to the generator, which creates the electrical current.
These wells on this well pad are most closely tied to the closest power plant behind me, Unit 14 Sulphur Springs Power Plant. But thanks to the steam lines that interconnect almost all the power plants here at the geysers, if the power plant behind me, Sulphur Springs, goes into an outage for maintenance, that steam can be rerouted to other neighboring power plants, allowing the steam to continue to be utilized and continuing to produce power.
We pretty much, every unit runs at half load or half capacity. That way, so say if 13 was the trip, 16's gonna take all that steam and they're gonna put that towards their generator. So we don't wanna push out 100 megawatts right here and plant 16 go down, because that's the way the steam line's gonna come. We're not gonna be able to produce any more power.
Some rough numbers, geothermal is about 6% of the generation of power in California, and the geysers is about half of all geothermal in California. So we're close to 3% of all the power generation in California, just here, Alpine geysers.
Although renewable, steam power is not an unlimited resource. It still has to be managed and maintained.
One consequence of the power production is that we do lose a lot of the steam mass to the atmosphere. 75% is lost to the atmosphere, 25% is recovered as condensate.
As the geysers was developed in the 70s and 80s, there ended up being a large decline in steam production because of overuse of the steam.
To maintain a steady steam output, Calpine needed to replace the steam mass they were taking out. So they entered partnerships with the communities of Clear Lake and Santa Rosa to pipe their treated wastewater up to the geysers and inject it back into the reservoir.
The high point tank for the water, the treated wastewater from Santa Rosa, is right across on top of that bridge there. It's a 1 million gallon tank where the water transfers from City of Santa Rosa to our Calpine system.
In the early days of production, there were many operators with their own goals concerning production of steam and generation of electricity. Since the field has been somewhat unified under Calpine and then under NCPA to the south, there's the ability to much carefully monitor the steam output and the water injection input to balance everything out and try to keep the reservoir in a sustainable state. We're doing a very good job of that. We have some very smart reservoir engineers that are looking at all the ups and downs in the steam production, and we're also looking at the water injection profiles throughout the field with our 50 plus injection wells. And by balancing all that out, it's been possible to date to achieve nearly sustainable production. We're on about a 1% yearly decline now, but that can be improved over time with additional understanding of the field and additional knowledge.
Thanks to combination of things, the addition of the recycled water that is pumped up to the geysers, the capital upgrades we've made, the efficiency upgrades, we're now fairly sustainable at roughly 6,000 gigawatt hours per year. Renewable power like geothermal is going to greatly help with issues like global warming by being a zero to very low carbon greenhouse gas emitter. Depending on what the comparison is, but compared to a typical thermal fossil-fired power plant, we're approximately 5 to 10% of their CO2 emissions. In other words, 90 to 95% fewer CO2 emissions per megawatt hour.
Just as the geysers' continued success is dependent on receiving treated wastewater, a pioneering strategy to use raw waste for power generation has been developed in Oakland by East Bay MUD.
The East Bay Municipal Utility District, or East Bay MUD, is a joint water and wastewater agency that serves in the eastern San Francisco Bay Area. On the wastewater side, we have almost 700,000 customers, mostly located in the cities of Berkeley and Oakland. And at our wastewater treatment plant, wastewater arrives in the sewer pipe. We receive an average flow of about 50 million gallons a day. And then it's put through several different wastewater treatment processes. And I like to think of them as using gravity and biology and chemistry to treat wastewater. The Resource Recovery Program was born almost 20 years ago when we realized we had a lot of surplus capacity. When this plant was designed back in the mid-70s, there was a food processing industry in Oakland, such as canneries, and they delivered a lot of waste to our plant. Well, over time, Oakland has deindustrialized, and that's left us with surplus treatment capacity. So we were thinking about, well, how could we use that to make sure that we fully utilize our wastewater treatment assets? And that's when we thought about allowing trucks to deliver waste that might be economical for them and where we might be able to convert some of their waste into energy by digesting those wastes. We've allowed trucks to haul commercial and industrial waste to our wastewater treatment plant for treatment. Initially, it was met with some resistance because this wasn't a normal thing for a wastewater treatment plant to do.
We take fats, oil, and grease from food and beverage industries. For example, chicken slaughterhouses, animal slaughterhouses, winery wastewater, wash water, brewery discharges from dairy processing facilities in the Central Valley, cheese manufacturing, olive brining. These are unique waste streams we're getting.
At wastewater treatment plants, fats, oils, and grease are known as fog.
We are currently at the fog receiving station. The truckers hook up and they are provided with a code. Then the valve will open and then they're allowed to offload into our fog tanks. We have like a 24-hour process that are offloading into our fog tank.
The R2 program sees between 100 to 150 tanker trucks per day delivering waste to the plant. And each of those tanker trucks, on average, can hold about 5,000 gallons of liquid.
They have to truck these wastes because some of the local treatment facilities don't have the infrastructure to handle large organic demand. Their only resource is to be able to truck it to our plant. We're one of the few treatment plants in Northern California that has the capability to handle these high-strength organics.
Setting East Bay MUD apart, trucks carrying waste that contains liquids mixed with solids are routed inside the plant, where they can be offloaded and processed at the Solid Liquid Waste Receiving Station. Diverting this hard-to-handle material from landfills, where it would off-gas methane, reduces pollution and keeps 8,000 metric tons of greenhouse gas out of the atmosphere.
Below me are two grinders, so it makes it easier to continue to pump contents to our blend tanks and the digestion process. The blend tank here is to help combine all of these wastes and then eventually feed into our digesters, type of like equal flow so that it doesn't upset the chemistry in the digesters.
put them in the anaerobic digesters, there are bacteria that degrade the waste. And in the process of degrading that waste, they produce a biogas. And the biogas is a mixture of mostly methane, but with some carbon dioxide.
So these right next to me are the digesters. This is where all the magic happens, and all of this high-strength waste and all the other types of waste forms the methane gas.
Above me is what we call our gas header, where it collects a biogas from each of the nearly 2 million gallon digesters. And then it's fed to our cogen engines. We have 3 reciprocal engines and a turbine, and we're capable of generating up to 11.5 megawatts of electricity.
Before the resource recovery program, our on-site generation could meet about 40 to 50% of our wastewater treatment plant electricity demand, which is typical for most wastewater treatment plants. In 2012, we became the first wastewater treatment plant in North America to become a net energy producer, meaning that we produced more power than we need to operate the wastewater treatment plant. Since that time, we've been in exceedance of 100% every year, and we're now between 130 to 140% of our plant demand. We sell this surplus electricity to our neighbor, the Port of Oakland, and we earn additional revenue from these power sales, which can then be used to keep our wastewater treatment rates low. Even though we've brought in these additional trucked wastes, we've managed to maintain a perfect compliance record. So we have not violated our discharge permit to the San Francisco Bay since the inception of this program.
I'm most proud of relationships I build with the industries that we work with. These industries don't have a place to find a home for this waste, and I feel like we're contributing to their sustainability goals and, again, helping save the environment.
Throughout the industry, I think we earned a lot of respect for developing this unique program. Wastewater treatment plants are not in competition with one another. And so one of the things that's been very satisfying that many other treatment plants, not only in the region but around the country, have adopted our model. And it's great to see them generating more renewable electricity, which is just great for the environment in general.
A few miles south of Oakland, in the city of Hayward, another facility has taken EBMUD's model and customized it, maximizing green power generation with the resources available to them.
Hayward's treatment facility is about 1/10 of the size of EBMUD, but they both have the same treatment processes. The city of Hayward also has a 1.6 megawatt solar facility that is producing a lot of power. Typically, a wastewater treatment plant, it's a large energy consumer because there's a lot of pumping with conveying the water.
About 2% of all the power used in the United States is used to move water and wastewater. If you look back in the city of Hayward, basically 20% of all the municipal power was being put right here in this plant.
The priorities for the Hayward City Council are safe, clean, green, and thriving. So given that green is one of our highest priorities for the city, sustainability is one of the significant concerns with everything that we do. Hayward was one of the first cities in California to adopt a climate action plan. The primary goals are to reduce greenhouse gas emissions on par with the goals of the state of California. It's difficult, but with the work that's being done here at the Water Pollution Control Facility, it's bringing us a big step of the way towards reaching carbon neutrality for municipal operations.
We have cogeneration and we have solar, and we have a 1.1 megawatt Jenbacher engine. It can actually be 1,573 horsepower when it's running on our biogas. The biogas comes from our digesters, methane gas. When we moved to the Jenbacher, we entered into a whole new realm. What we started doing was producing 1,136 kW, higher than our plant demand. That's enough to power approximately 900 homes.
We've got an agreement with PG&E, the Renewable Energy Self-Generation Bill Credit Transfer Tariff, where all the excess energy that we produce is used to offset bills for other city facilities. The city of Hayward is really fortunate to have a lot of property located to the west, and in that area was where we installed our solar.
Solar field was built in December of 2010, and when that was complete and we started up, it took off. It was literally hit the start button and we started making energy. Now that is a little different because it's subject to weather. Obviously you have rain, you have darkness. We monitor it daily and just keep producing energy with it. The best performance is when it's sunny and it's, kind of cool, like in the springtime. Our primary objective here is treating wastewater and taking care of the environment that way, but this sustainable process that we're now into is very big.
One of the most exciting things about the water pollution control facility is the employees that work here are always working to improve efficiency and to increase the generation of renewable energy. There's great things on the horizon.
The city has plans to be zero net energy by 2025, and the solar facilities are essential for achieving that goal.
It's an amazing thing what we're doing here, and we're very proud of it. We want to make sure that, we're using the resources available to us and we're making the most out of them, not only for our ratepayers, but for future generations.
Future generations are the priority, not only in Hayward, but also in the Unified School District of Pittsburg.
Pittsburg is East Bay District and 40 miles outside of Oakland. Very diverse community, 11,730 students.
We have 13 school sites, many wonderful programs to help support our scholars and our community. We really work to embrace sustainability as it relates to students' health and the health of an entire community. We have solar microgrids at each of our schools.
We have a 1 acre area of land that is a bioswale intended for stormwater retention. This bioswale needs to have a layer of vegetation growing in the floor of it to be able to be successful. At UC Santa Cruz, they developed a new solar panel, and it allows the red light needed for photosynthesis to go through the panels, allowing vegetation to continue to grow underneath it while it captures the green light necessary for solar production.
In addition to the 178 kW solar panels, we also have 4 20 kilowatt hour wind generators. One thing about Pittsburgh, it's not always sunny, but it's typically windy. Even when the sun goes down, we're still generating some renewable power.
Honestly, I like to come out and just watch them spin. It's mesmerizing.
The board is very supportive of this project. It allows us to have the solar system and turbine system to take us off the grid. The transportation piece of it is fantastic. Our district is one of the first few districts to actually have electric buses.
We now have 4 electric school buses on the ground that do routes on a daily basis.
We did receive from PG&E the 9 stations to charge the buses.
Our school bus drivers are enjoying the vehicles because they are quiet. They have a song that plays if it's traveling under 15 miles an hour or it's stopped at a stoplight.
There we go.
It alerts individuals to know that this bus is actually on and moving. This is our Bioswale Learning Center. The Bioswale Learning Center is something that is an amazing project where we can actually have scholars come out to the facility and they can see how the solar power that's generated is put back into the grid.
We've pulled students from the environmental science classes to come here and give input into what they'd like to learn and how they'd like to design curriculum for the students that'll come through here.
There's an educational center where elementary kids and high school students can go.
It is really important for the students to be involved because we're the next generation and we know that the planet is in danger right now. When I was younger, I never got the opportunity to even know what renewable energy was until I took it. So with this new learning center, now we have an opportunity to teach the younger generations about renewable energy.
Everybody jumped on board to help create this curriculum, and we have it developed in English and Spanish.
It's not just words that we say. Environmental stewardship, it plays a role in every decision that we make.
Exploring renewable power options is an important way to steward the environment and to keep the Bay Area bountiful.
We're able to make a positive impact for our environment around us by converting some of the waste that we received into energy